a smarter model can still make a terrible agent. On July 15th, XAI open-sourced Grok Build, the system around its coding model. The repository includes the runtime, tools, workspace controls, checkpoints, sandboxing, skills, hooks, MCP, and subagents. That release exposes what benchmark charts leave out. The model is only one component. If context, permissions, memory, or verification are weak, frontier intelligence can still fail at ordinary work. I run AI agents across research, files, content production, and business operations. I have also watched newer models make the same operational mistakes as older ones. They use the wrong file, call the wrong tool, lose the state of a task, or confidently declare completion before the output has been checked. Those failures look like intelligence problems from the outside. Most of the time, they are system problems. So instead of asking which model is smartest, this video asks a more useful question. What has to exist around a model before it can become a reliable agent? Start with the basic distinction. A model is a reasoning engine. It receives input and predicts a useful response. An agent is a system that gives that model a job, information, tools, boundaries, state, and a way to judge the result. Think of a brilliant contractor arriving at an unfamiliar company. Intelligence does not tell that person where the files are, which systems they may access, what needs approval, or how the company defines done. The surrounding operating system provides those things. That operating system is the harness. The public Grok Build repository makes this visible. The model call sits inside a larger runtime that assembles context, dispatches tools, manages the workspace, creates checkpoints, and loads extensions. Open sourcing that layer does not prove Grok is the best model or the best agent. It proves that the execution layer is now important enough to be a product in its own right. The first layer is context. An agent needs more than a long prompt. It needs the correct rules, the relevant files, the current task, and enough business meaning to choose between plausible actions. More context is not automatically better. A giant context window filled with stale instructions can make the agent less reliable. Good context engineering decides what enters the working set, what stays outside, and which source is authoritative. If an agent edits the wrong repository or follows an outdated policy, the model may have reasoned perfectly from the wrong facts. A model upgrade can reduce confusion, but it cannot identify a source of truth that the system never supplied. The second layer is tools. A chatbot can explain how to do a task. An agent needs verbs. Read the file, search the web, update the calendar, run the test, render the video, or send the approved request. Tool quality matters as much as tool availability. Names must be clear. Inputs must be structured. Errors must return useful information. And the agent needs feedback from the real environment after every action. Anthropic describes this as grounding the loop in tool results and other environmental truth. Without that feedback, the model is not operating. It is imagining that it operated. The third layer is permissions. Capability without boundaries is not autonomy. It is uncontrolled access. A useful harness separates reading from writing, local changes from external actions, and reversible steps from destructive ones. It can allow an agent to inspect a calendar but require approval before sending an invitation. It can allow a draft but block publication. It can keep secrets outside the prompt while still letting an approved tool use them. The right question is not whether the agent can do everything. It is whether the system grants the minimum authority needed for this step and can stop before the risk changes. The fourth layer is memory and state. These are related, but they are not the same. State answers, where is this task right now? Memory answers, what should persist across tasks? A chat window can hold recent conversation, But that is not durable operational memory. The harness has to store decisions, progress, constraints, and results in a form that can be retrieved later. It also has to forget or archive information that is no longer valid. Otherwise, the agent either starts from zero every time or carries old assumptions into new work. An intelligent model with broken state management behaves like a talented employee who receives a fresh desk and no handover every morning. The fifth layer is verification, and this is where many impressive demos collapse. A model can produce an answer that sounds finished. A harness needs evidence that the task is finished. For code, that may be tests, a build, or a diff review. For research, it may be source coverage and claim checks. For a video, it may be a full decode, duration alignment, audio levels, and representative frame inspection. Verification also needs stopping conditions. If the same failure repeats, the agent should not burn unlimited time and tokens trying the same action. It should change strategy, request a decision, or stop with a precise blocker. Reliability comes from the loop between action, evidence, and correction, not from confidence in the first response. Producing this channel. In one failure, the 11 Labs key existed, but two parts of the pipeline expected different environment variable names. The model did not need to become smarter. The harness needed a normalization layer so both names resolved to the one variable the speech system expected. In another failure, scene files were rendered into an external output folder, but the final concat step resolved their paths incorrectly. Again, the script and the model were not the problem. The path contract was. The fixes were deterministic. Normalize the credential name, resolve media paths from the actual output directory, pass the real duration into the composition, and verify the final file. The same intelligence produced a more reliable result because the environment improved. XAI is not alone in reaching this conclusion. OpenAI's harness engineering report describes early progress being limited by an underspecified environment. When an agent failed, the useful question was not how to prompt it to try harder. It was which capability, tool, abstraction, or feedback loop was missing. Anthropic makes a similar recommendation from another direction. Start with simple, composable patterns. Make tools legible, keep agents grounded in environmental results, and add complexity only when it measurably improves the outcome. Different products use different terms, but the pattern is consistent. The model provides capability. The harness turns capability into repeatable work. Practical checklist for evaluating any AI agent. First, context. Does it know the rules and the authoritative source for this job? Second, tools. Can it take the required actions and observe what actually happened? Third, permissions. Which actions are automatic, which need approval, and which are blocked? Fourth, memory and state. Can it resume the task without inventing or forgetting decisions? Fifth, verification. What objective evidence proves completion, and what happens when that evidence fails? If a product page only tells you which model it uses, you still know very little about whether the agent will work. Ask about these 5 layers before asking for another benchmark chart. Model improvements matter. Better reasoning raises the ceiling of what an agent can do, but the floor is set by the system around it. A weak harness turns a frontier model into an unreliable assistant. A strong harness makes the model more useful, more controllable, and easier to replace when something better arrives. Grok Build. Becoming open source is important for that reason. It lets us inspect the machinery around the intelligence. The next AI race will not be won only by the smartest model. It will be won by the system that can turn intelligence into verified work.